In this demo, we'll learn about handling faults and avoiding to expose implementation details. First, let's simulate a fault. When getting the authors, I'm going to throw a new exception. Let's build and run this. And let's send a request to get the authors. And there we go. We get back a 500 internal server error and a stack trace. Now, is this okay or isn't it? Well, during development, it is okay. We want to be able to easily find out what's going on while developing and testing. However, in a production environment, this absolutely is not okay. It's actually a security issue, as you're exposing implementation details to the client. Moreover, it's also useless. The consumers of your API cannot fix this anyway. It's a server mistake, a fault. They don't have any use for the stack trace. Now, let's have a look at what's causing this. Let's open the Startup Helper Extensions class, where we set up the request pipeline. What's causing this is the developer exception page middleware. This ensures that we nicely see the stack trace. And as you can see, it's been set up to only be added to the request pipeline when we're in a development environment. So let's switch to the production environment and see what happens. We can do that in the launch settings.json file. So let's switch to production by changing ASP.NET Core environment to production. Let's save, and let's try that again. We're back in Postman, let's send the request again. And there we go. We get back a 500 internal server error, but without a stack trace, as it should be. In older ASP.NET Core versions, you had to write a bit of code for this to function. Today you get this out of the box. Yet, it still is important to consider this for a few minutes. It's easy enough to make a mistake here, like always showing that developer exception page regardless of the environment. And that can have dire consequences. By the way, it's not because you get this out of the box that you can't manipulate it. What happens is that ASP.NET Core out of the box used the default exception handler middleware, which gives us that 500 internal server error without a stack trace. Instead of letting it implicitly use it, we can be explicit about this. We state that whenever we're not in the development environment, we add a regular exception handler middleware to the request pipeline. And we can now configure this and change its behavior. Let's say that we want to show a generic error message. There's an overload available here which gets us an application builder, and we can use that to completely customize this. So we pass through a lambda that returns that action on iApplicationBuilder. We can then call run on it to pass through a piece of code that will be executed if this place in the request pipeline is reached. In our case, that means that this piece of code will be executed when an unhandled exception happens in our code and we're not running in the development environment. In that case, we set the status code to 500 and we write out a generic error message as the response body. For that, we can call the writeAsync method on context.response, passing through the string we want to output. You can do additional things here as well, like logging the actual problem. Anyway, let's give this a try. Let's send this request again, and there we go. We still get back a 500 internal server error, but this time our custom message has been written out to the response body. Alright, let's switch back to the development environment. And let's get rid of that test exception. There we go. Let's continue by learning about the payload of a request or response.